Ifeanyi Vivian. He is an early career researcher, a dedicated PhD student in environmental biochemistry. Her research focus is on the remediation of polluted environments, reflecting her passion for creating sustainable solutions to environmental challenges. She is a member of the National Society of Biochemistry and Molecular Biology, as well as the West African Society of Toxicology and the Organization for Women in Science for the Developing World. She is known for her enthusiasm for knowledge, her openness to learning, and her commitment to continuous growth in her field. So please join me in welcoming our dear sister for this insightful presentation she will give us today. Please clap for her.
Good afternoon, great women scientists. Thank you so much for this privilege. Before I start, I would like to ask us a few questions. The first one is, are we aware that Nigeria is very rich? As Nigeria as a country is a very rich country. Are we all aware?
Yes, we know.
Okay, the second question is, how come our youths are leaving this country and they are jumping as the world and they are just leaving the country? And the funny thing is, they go there and start washing plates for them to earn money. Early this month, a friend of mine, a business partner, came to our company and then he invited us for a dinner. So while we were there, he was sharing something with my husband. He brought this menu. There's this particular vegetable we're eating, and he said this can only be found in China. And he told my mother, he said, my friend, do you know that people are here, that there are people are here in Nigeria farming. They bought lands and they are farming in Nigeria. And I looked at my husband, he also looked at me, and we were shocked. So, you see, they come here, they know what we have, they know the natural resources we have in this country. So they come, they utilize it, they make money. And we here, we're just going to foreign countries to look for something elsewhere. Anyway, back to why we are here for today. We're looking at agricultural waste as a sustainable solution for polluted water treatment. We evaluate hybrid bioabsorbents in the Niger Delta. Next slide, please. As a way of introduction, the Niger Delta is rich in oil and gas, but face environmental challenge as a result of oil exploration. And one major cause is the pollution of our water bodies from what we call produced water. Produced water is the water that comes out with crude oil when they are being extracted. That's when it's being extracted. During the process of extraction of crude oil, this water that comes out with it. And you know, the water is not needed because what is needed is this crude oil. So the question is, what happens to this water that is not needed? This water is being treated and then discharged into the water. Some persons don't treat it, they just discharge it into the environment, into our water bodies. And when this is done, what happens? The quality of water is being degraded, aquatic lives are affected, and then we as humans, our health also is affected. And so there is need to treat this produced water for a healthy environment. So when you're eating fish, if you say, I don't eat red meat, I want to eat fish, you're sure of what you're eating. Because this produced water contains toxic compounds. Yeah, they contain heavy metals, hydrocarbons, and other salts that are very toxic to our health. That's why I advise people, when you want to eat fish, please avoid a head, because this is where the heavy metals are being deposited. Okay, so scientists, there are methods that exist to treat this water before they are being discharged, but these methods are complex and they are also expensive. And so we are looking for sustainable ways that are eco-friendly, can be used to treat this produced water before it's being discharged into our environment. Next slide, please. And that's what brings us to what we have today, agricultural waste. The slide there, you can see the agricultural waste. The first one there, on our left, is the hamburger seed. And this one is avocado pear peel. Most of you know this. The Igbos call it upo. Upo, okay, upo. Sorry for the transition. I'm from Igbo. The Igbos call it upo. And it is a hard nut. So this coat, once you take the edible parts, what you do is just discharge that one. You discard it. You don't use it for anything. Same as this your avocado. After eating it, you take this peel and discard. So this material, agricultural waste, we're were used to produce something, absorbents, to treat water pollution, to produce water. Please, next slide. Okay, the aim of this study is to evaluate the effectiveness of hybrid bioabsorbents derived from agricultural waste in the treatment of polluted water in the Niger Delta, and these are the objectives. First, to investigate the effects of different optimization conditions on the iodine absorption capacity. I'll come back to this. The second one is to examine the physiochemical properties of the produced water treated with the activated carbon of study and also with commercial activated carbon. Next slide, please. Okay, this is the previous one. The method. This agricultural waste we are gathered. Okay, I bought the fruit. Let's just share the method. I got this fruit from a local market. We took away the edible parts, then the waste. What we did was we gathered them, washed, and dried them, and then prepared what we call activated carbon by ashing them. After that process, we went further to activate them. We just prepared the natural carbon. After that, we activated it. The essence of this activation is to make it more porous, so you can be able to absorb more contaminants. So we use zinc chloride to activate it, and then used to treat produced water that was gotten from brass terminal. It was treated, and then the filtrates were run analysis to discover the state, to determine the state of this water after the treatment. Then fish bed absorption study was carried out. Like I said, something that looked like a column was prepared. A wooden glass was placed under it to prevent the activated carbon from going out. So we packed this activated carbon that was prepared into that column and then allowed the water to pass through it, filtering that water. The filtrate was then analyzed. We can see the results of it. Okay, like I said in the objective, that the first one, we are trying to determine the effect of different iodine absorption capacity. That's what I was trying to say there. We have impregnation concentration, impregnation ratio, the temperature time, conversion time, temperature, and this is capacity. We use 4 different concentrations of the activating agents. That's the zinc chloride. 0.5 mole per dm cube, 1 mole per dm cube, 1.5, and so. And from our results, when the 1.5 mole per dm cube did better than other concentrations. So this is what we use to treat the water. This was just a test to know the concentration that will give us the best results. And then we got the one of 1.5 as the best that gave us what we needed. And so this was what we used to treat the produced water. You can also see the graph. The big there shows us that this is 1.5. You can see it from the graph there. Next slide, please. And then this is the results. These are the parameters of the water, the untreated water, untreated produced water, the PW is produced water. We have the treated. This is activated carbon. This is the results. That HAAC there, hamburger, avocado, activated carbon. That's just a short abbreviation. And then treated with this. These standard by regulatory bodies, DPR and EGASP, to test. Next slide, please. Next slide. This is also a graph to represent what I've just said. So, in conclusion, the physiochemical parameters of the water analysis show that this activated carbon performs significantly well comparable to the commercial activated carbon, and it improved the water quality, the parameters, and brought them to required standard by the regulatory bodies. This next slide. Okay, recommendation. I strongly recommend that there should be further development and application of hybrid bioabsorbent from other agricultural waste to treat pollution in Niger Delta, and also that government agencies as well as regulatory bodies should employ the use of this activated carbon in community scale water abuse treatment. This is a way to mitigate pollution in Niger Delta, at the same time managing waste. And then finally, it's not on my slide, I want to encourage OWSD members to see this as a planning source of income. Yes, because the activated carbon I bought, the commercial one I bought for this study as a control, let's tell you how much I bought in a very small quantity for 6,000 naira. So you can just do this because you have nothing to lose at all. You get your avocado beer or any other plant. After consuming it, what you do, produce it, it's very simple. You ash it, activate it, and and then package it neatly. You can just do V and V activated carbon and start selling to make money. It's not just a treat water, there are other things you can use activated carbons to do. Thank you so much for your time.
But I have a question. You know, I would have liked to see the ashen picture. You know, I think that's the main thing. I saw the waste, but I didn't see the ash. It's the way you want it, and so that I will also know that it's possible for me to ash those things. Then another question is, I don't know, the term impregnation. We know impregnation as somebody that is pregnant. So I don't know what it's doing here. I would like you to explain to me. Thank you.
Thank you, ma'am. The impregnation concentration means we got the 1.5 for different concentrations, and then you soak. It's called soaking. You soak it. That's to impregnate it. You get your carbon. You submerge. You mass. No. You get it. The zinc chloride, the liquid form of it. Then you get your carbon, the one you've ashed already, soak it together. That's what we call impregnate, to submerge it. I don't know if I've explained.
We want to know if there are tests to run to ascertain plants that are bioabsorbent. Is there any kind of test to run to know if these are plants that do the work? And number two, you talked about a filtration process, like President stated. It would have been nice, the picture of that. If the picture, if you show us the picture, so we understand what is going on.
Okay, they're actually carbonaceous compounds that are high in carbons. So you can just Google that. This particular fruit, does it have high carbon? So that's one of the ways to do. Then you know, when I have the pictures in my phone, maybe I will include it.
My phone is on the lighter side. You kept calling it half water plant. What makes it half water plant? Because it has the scientific name. Half water plant. Mukuna is half water plant. And then purification of water. Is it as by drinking water or as what?
You can use it to treat any kind of water. Remember, we're looking at if you don't treat that produced water before discharging it, even if you don't drink the water, you eat fish from that water. Looking at how healthy that water is before you discard it. You can use it to treat any water. It's very good. It's very healthy. Activated carbon for consumption. You know, when I was in secondary school, there's this my friend. Every time you see the mom, she's with charcoal in bottled water. I keep asking, I keep wondering, what's this? It's until this study I noticed that this carbon does a lot of things to our health. Both poison, there's so many things carbon does to the health.